This is the introduction to the gas thermometry experiment, in which you'll determine an experimental value of absolute zero. The goals of this experiment are to learn how to use a helium gas thermometer and use it to measure the temperature of various baths that are at phase transitions by monitoring a change in pressure. You'll create a calibration curve of those temperatures versus pressures and extrapolate to find absolute zero. First, we need to talk about compressed gas cylinder safety. You're going to be using a helium gas cylinder in this experiment, and you'll be interacting with it very little, but you need to make sure that it's set up safely. First of all, make sure that it's attached to the bench securely and that all connections to it are tight and well made. A gas cylinder is very safe to use if it's set up properly. If it's not set up properly, it can turn into a rocket, punch holes in things like walls or you. On top of the tank, attached to the top valve of the tank, should be a pressure regulator, and a regulator is there to control the flow of gas out of the cylinder. It's attached to the tank valve, which comes up vertically from the top of the cylinder and is there to keep the gas in. When you open the tank valve, gas proceeds into the regulator, but not necessarily out to the manifold yet. The valve on the right side of the tank, closest to the cylinder, tells you how much gas is in the cylinder, and you need to keep an eye on this to make sure you don't run out during the experiment. The other gauge tells you what pressure will leave the regulator. For the gas thermometry experiment, this should be a very small pressure because you don't need very much helium at all. You can set that pressure with the output pressure control, which is this knob in the middle of the regulator. Turning it to the left reduces the pressure that's going to leave the tank. Turning it clockwise to the right increases that pressure. Once you have your pressure set and you're ready to let helium flow out towards your manifold, you can use the regulator output valve and open this valve to send gas to your system. The other part of the system that's not the helium cylinder is made up of a vacuum manifold and a vacuum pump and then a thermometric bulb with a pressure transducer. So you're going to set all this up, put it all together, and use it to measure the temperature of systems that are at phase transitions. A schematic of the manifold can be seen here. So the manifold is just a glass tube with a pressure gauge on top of it, and it has some valves coming out of the bottom, and these valves can be used to attach different things to the manifold. So the manifold is going to serve as a go-between. You're going to put helium in it, and then you're going to send that helium to your thermometric bulb. The bulb has a pressure transducer on it, which produces a voltage as a function of pressure. It's attached to an amplifier circuit, which has been built for you rather than making you build another one. And you can read the voltage coming out of this amplifier with either a multimeter or your MATLAB program that you wrote for your thermocouple. So the procedure. First thing you're going to need to do is to make sure all the connections are made securely. So in addition to the ones on the helium cylinder, you're also going to need to make sure that your thermometric bulb is connected to the valves that are on top of it and also connected to the manifold securely. Once the pump is turned on, you're going to need to evacuate your whole system. Any air in the system is going to give you bad results. So you'll close the helium tank, open all the other valves except those that aren't attached to anything, and pump on all of the system. You want to wait a few minutes because pumping efficiency goes down as pressure goes down, so it's harder to get the last little bit of air out of the system. You want to measure, both with the pressure gauge and the pressure transducer, the evacuated pressure of your system. It might not be 0 torr, it probably won't be, but it should be very close. So you're going to get this number off of your pressure gauge. You should also get a corresponding voltage from the pressure transducer. The way that these pressure gauges work is that they read the pressure below atmospheric. So 0, the number 0 on the gauge, corresponds to the pressure in the room. Numbers below that correspond to reduced pressures. So you're going to need to subtract the pressure on the gauge from the atmospheric pressure in the lab to get the absolute helium pressure inside the manifold or the thermometric bulb. When the system is pumped out, you need to close the valve between the thermometric bulb and the manifold and watch the value on the pressure transducer. If the voltage starts changing, this implies that there's a leak somewhere in your thermometric bulb system, which you need to fix before you move on. Your TA can help you with that. When you're ready to add helium to your system, again, you're going to add helium first to the manifold, and then from the manifold to the thermometric bulb. You're never going to flow helium directly from the tank into the thermometric bulb. The manifold can handle it if you overpressurize it to a small degree. The thermometric bulb cannot, and the pressure transducer certainly cannot. So you're going to put a small flow of helium into the manifold through the valve on the manifold until the pressure gauge reads about 200 millimeters of mercury. And then you'll close the valve on the manifold and then close the tank valve on the helium tank. At this point, you're ready to send helium into the bulb. So you'll open the valves between the bulb and the manifold. Again, for all of this, the pump should be off. As the helium expands into the thermometric bulb, the pressure read on the pressure gauge is going to decrease because now that helium that was in the manifold is now spread out through the manifold and the bulb. So the pressure will go down, and it should go down to about 150 to 170 millimeters of mercury. If it's much higher or much lower than that, pump everything out and start over. At this point, you should remember to record the room temperature, the pressure in the room, and the initial pressure reading in your thermometric bulb, which is the same as the pressure in the manifold at this point. After you've done that, close all the valves and detach the thermometric bulb from the manifold at the connection that's shown here. You're going to move the bulb and physically put it into the different phase transition baths. So you're going to submerge it in ice water or in a steam bath or whatever. And you're going to record the multimeter voltage or your MATLAB voltage at these different temperatures. A separate part of the experiment involves calibrating this pressure transducer. So whether you collect with a multimeter or with MATLAB, you don't have a calibration value between pressure and voltage. So you're going to need to generate that yourself. So what you'll do is put a large amount of helium, 500 or 600 torr, in the manifold and the transducer. They should be open, and the thermometric bulb rather, they should be open and connected together. You'll read the pressure, read the voltage, and then open the pump valve just a little bit, pump out a little bit, read the new pressure, read the new voltage, pump out a little more, etc. I don't think anybody's going to need to share a manifold this semester, but if you do, one group should do this while the other group is putting their thermometric bulb into the various temperature baths, and then you should switch. Once you have all your voltage versus temperature points, you're going to do your data analysis. So the temperature and the pressure are related by a proportionality constant that's discussed in your lab manual and your textbook, so I won't discuss it anymore here. All these baths are at phase transitions, so you should know the temperature accurately, either by calculating it with the Clausius-Clapeyron equation or by measuring it with your thermocouple. You should not attempt to use your thermocouple to measure the temperature of liquid nitrogen. You should convert all these voltages to pressures using your calibration curve and then plot the measured pressure versus the known temperature. Extrapolating this plot to zero pressure will give you the experimental value of absolute zero.